Okay, now we're having an in-class session right now. But right now I'm going to address the distance students just for a couple of minutes while everybody in class uh, writes a little information. And if you're writing that information in class, tell me a little bit about yourself too. What are your goals? What's your ambition in life? What things you like, and so forth. Okay, now addressing distance students specifically. You have homework problems on OpenMath. Hopefully you've followed the instructions at Canvas, although I see only one person who's registered in both the, well, actually, I only see one person who's registered for OpenMath among distance students. So if you're a distance student, get on the ball and do that. If you don't know what to do, look at Canvas again, see if you can follow the instructions one by one. And if you run into something you can't do, tell me what it is. It's not working for you, what you're trying to do, and email me and I can straighten that out for you. Okay. I'm Dave Smith, instruct this course. Hopefully you've read the syllabus, which we'll go over in some detail in class next time. Now, as a distance student, you're required to view these videos. If you have an alternative way you'd like to learn the course, please let me know. I might well approve that. But right now, that's the bottom line requirement. The bottom line in the course is you want to pass it with a satisfactory versus an unsatisfactory. And the strategy for doing that is to do your work diligently. Don't use AI. Don't use Chegg. Don't use online resources to do your homework for you. This is the second year in which I've offered these courses as a distance option. And 80% of the students who've taken this course as distance students have made pretty much 100 average in all their homework and under 25% on their tests. That tells me that most students, I can't judge which students are, which students aren't, but it tells me that most students aren't doing their own work. Okay, so you are required also to keep a notebook, and you will be required to send me copies of your work. You can use a scanner app. That's very easy. If you don't have a smartphone, email me. We'll figure out an alternative way for you to do that. Okay. So number one thing I say is do your own work. It's the tests that determine more than anything whether you pass. Homework is a small percentage. Also, there's a quiz at the beginning of every class, and I'm requiring you to take those quizzes, whether you use any other means or not of learning the material. There are other alternatives. You take the quizzes, which means that you watch the videos, you get the quiz at the beginning of the class, you do the work. You don't watch me work it afterwards and then do your work. You do the work immediately. Okay. Now I say that, kind of a little bit strictly because I find that it's necessary. Probably not, certainly not for every one of you. There are distance students who've done the course honestly and had success in the course. But the success rate's very low for distance students because of what I've been talking about. Because it's pretty obvious to me that most students are not doing their own work and not doing the work that's necessary to learn the material. Okay. So we're going to proceed with class, and I'm going to do a couple of, it's kind of a pretend quiz just to see how people do on it. Okay. And we're going to go on from there. Okay, this isn't a quiz, but still, district students want you to work these. And when you're done working them, download a scanner app if you need to. Scan the thing and send it to me. Okay. And then I'll go over it, but do it first. Okay, the quiz is, I've taken up the quiz. If you're a distance student, I'm gonna work the quiz first. So we start with 5/7 plus 3/7. Now, the logic of this is, well, 5/7 plus 3/7 is what? Well, we got sevenths, you're right. We got, how many sevenths do we have? We have 5, right? And we have 3/7 here, right? Now, if we got 5 of something and we got 3 of something, how many do we have? We have 8. Okay? And of course, that's 8/7. So that's what we get. Okay? Now, the rule is, that's a common sense of the rule. The rule is, if you got the same denominator, you can add the numerators. You don't add the denominators, which is a little confusing because when you multiply fractions, you do multiply the denominators. Well, there's a reason for that. The reason you can add the numerators if you've got the same denominator is, again, this tells you how many sevenths you have. This tells you how many sevenths you have. So you have this many plus this many sevenths. Okay, that's the intuitive reason behind the fraction. And fractions are going to be very important, especially for people, which many of you do have, who have pre-calculus in their future. Okay, one of the biggest stumbling blocks in pre-calculus is when we get to adding rational expressions around midpoint of the course, and people don't know anything about fractions. And there's a reason for that. It's because people don't know fractions very well, because about 5th grade, you learn fractions, and then somebody puts a calculator in your hand, and you never have to think about what they mean again. And the curriculum does not reinforce knowledge of fractions. It's a common deficiency. Almost everybody who comes out of public schools has it. Okay? But it's not that difficult. 5th graders can learn it, so can you. Okay? Because your brains are much better developed than 5th graders. Okay? I've got a grandson who's a 5th grader. You got a couple really smart parents, and he has some. My daughter didn't get that from me, but hopefully he's going to do really well. Anyhow, we have this. Okay. Now the next thing is this. Okay. Now, if I write this in standard notation, I got 5 times 2 to the 3rd. But the question is that 2 to the 3 minus 2 plus 4 plus 3? Or is the 2 to the 3 minus 2 plus 4 plus 3? Okay.
With the order of.
Which way is it? Oh, yeah, another thing is never talk while I'm doing this. It's just simply not that I mind. I would love it if we could do that, but since I'm recording, privacy laws dictate that if there's anything that could identify you, we can't use the video. Okay. But I'm glad you had an answer there, and I'm going to pause the video. So if you're going to say something, because I'm usually always kind of have an eye on you, just gesture, and I will stop the video, answer any question you have, or listen to any comment you have. Okay. From there. Okay. Now, I have question marks after both of these. It's a good thing because they're both wrong. Okay. But the comment I had was, well, order of operations. Somebody's talking about order of operations. Well, exactly. That's exactly what's going on here. And you have to know the order of operations in order to properly evaluate expressions. You're going to have homework on that. Probably before Tuesday. Okay. So what I'm going to say is, well, neither of these is right. And here's the reason. It's because the one operation that has precedence over all the others is exponentiation. Of course, if there are parentheses, you gotta do whatever's in parentheses first. And everybody pretty well knows that, so I didn't bother putting parentheses in this. I wanted to emphasize the order of operations. So this would be 5. And, if you're not aware of the order of operations, you could do them left to right, okay? If you do them left to right, you're gonna multiply 5 by 2. And you're gonna have a 10. And then you raise 10 to the third power, that's gonna give you 1,000, and already you're way off, right? So what you do is you do exponentiation first. So I'm gonna just write this. Like so, okay? Just 2 to the third power. Now, that's pretty easy. We do the third power. Now, some people will multiply 2 by 3 and get 6 because it looks about right, and it kind of makes sense, but that's not what exponentiation means. It means 2 times 2 times 2. And I think everybody knows that, okay? So I'm going to assume everybody knows that. And 2 times 2 is 4, and then times 2 is 8. Okay, now what do? Do we do the 8 minus 2? No. Do we do 5 times 8? Yeah, not because we do them in the order they're written, but because multiplication comes before addition or subtraction. So we have 40 minus 2 plus 4 plus 3. And then we just do additions and subtractions in order. So we're back, in this case, we're back to the order in which they're written. And if you have multiplications and divisions, you do them in the order that they're written. Okay? So you got to get, well, I'll do them in order. 40 minus 2 is 38. Now you won't go to this much trouble. It doesn't take long to write it. And 38 plus 4 is 42. And 42 and 3 is 45. Okay? So I don't think you'll have any trouble with it because the OpenMath will give you a good explanation, good set. Don't know how far you've been into OpenMath. Some people have been quite a ways into it already. You see that the way the problem sets are constructed is usually I've chosen to put problems with some video explanation before anything else. Okay. That in conjunction with, or maybe all you need is what you pick up in class, because they usually give you pretty much what you need. Okay, but the videos will support it, and you can go elsewhere. When I say don't use online resources to do your homework, I don't say don't use online resources to learn what you need to do your homework. Okay, you can use Khan Academy, I think is great. Okay, there are all kinds of online resources. If you search for order of operations, you'll get 68 billion responses. Okay, maybe not that many, but it wouldn't completely surprise me. It'd be way up in the millions, tens of millions at least, on order of operations. Okay, it's all over the place. And it's perfectly fine to look for other explanations of order of operations. Okay. Just use your judgment and make sure you're getting a reliable source, although I don't think I've ever seen an unreliable source. That some explanations are better than others. If you find some place that explains it to you in a way that you understand it better than others, by all means use it. You can even use AI to do it. If you ask AI a question, say, can you explain the order of operations? You get a pretty good explanation. If you don't like the way it's explained, you say, hey, explain it a different way. You get all kinds of explanations. You got to be a little careful with AI because sometimes it goes off the rails. Okay. One example, back over a year ago, I just said, okay, let's ask AI to generate a set of linear equations in this form. That would look like the AX plus B equals C, where A, B, and C are integers, okay? Or random integers between 1 and 20 or something like that. It doesn't do that. Okay, it generated 20 of them, perfectly good problems, no duplications. Now I also ask it to give the solutions. And, after it gives the problems, give the solutions. None of the solutions were right. They had nothing to do, it just made up numbers. Okay, now I think it might be better than that now. And also, if you wanted to do the mathematics right, there's a connection with Wolfram Alpha. And I don't know exactly how that works, because I haven't had the occasion to really care much about it, or haven't had to ask it anything. Where the AI does have a powerful mathematics engine, very powerful mathematics engine. You wouldn't believe how powerful it is. It's way beyond anything I know, and I know some stuff, okay? Way beyond anything that people that know 10 times as much as I do know. And I mention that simply because AI is going to be part of your life. Probably going to be part of your work life. Okay? You have to know how to use it. And you have to know something before you know what to ask it. Okay? If all you do is ask it something, you have no idea why you asked what, that's not worth anything. Nobody's going to pay you to do that. Okay? Let's see. Probably for information, so you can make intelligent decisions and so you know things. Use it appropriately. Don't use it to do your homework problems. First place, it'll probably lie to you. Probably not, actually. That's the right one. But it might. But by all means, whatever resource works for you is fine with me. I just want you to learn the material. If you can learn from what we do in class, well, hopefully you do. Okay. If you're a distance student, well, you're at least required to do the quizzes in 17. And then I would say do the quiz, honestly, and then look at the solutions, and then write a little bit about what you learned, if anything, from what I did. Or you say, I already knew how to do this, I didn't learn a thing, but here it is. Okay, I'm okay with that. You can even get insulting if you want to, but I get insulting right back, so be careful. Okay. I'll tolerate a lot. Okay. So hopefully some of that makes sense. Now we're going to solve this equation. We got 3x minus 2 equals 13. Okay. Now, the way I will solve this is I'm going to say 3x minus 2 plus 2 equals 13 plus 2. I might even underline the 3x minus 2 and the 13 because that's what I started with, and emphasize that I've added 2 to both sides. Okay? Now, most people do it a different way that I don't want you to do unless you do one extra thing. And I'm going to explain it to you in a minute. Okay? But let's go with this. Negative 2 plus 2 is 0. This gives us 3x equals 15. Now we can divide both sides by 3. And we get x equals 5. Okay? Now, within 2 weeks, we're going to get into solving linear equations and stuff. Incidentally, another thing I didn't mention at first is this course is intermediate algebra, but I've never found even a pre-calculus class that was ready to do intermediate algebra. Okay? In this class, we're starting with elementary algebra. We spend about a third of the semester on elementary algebra, so you know enough to do the intermediate algebra. It gets a little tougher. Okay? We started with the intermediate algebra. 2/3 of my pre-calculus students would be lost. We're working here at the intermediate algebra level to bring people up to the point where they can do pre-calculus or another math course that requires some algebra. Okay. So we're doing elementary algebra right now. I should clarify that. And will be for about the next 5 weeks or 5 weeks. Okay, so there's our solution. Now, the way people often do this is they'll write it like this: 3x minus 2 equals 13 plus 2 plus 2. Okay? And then they'll add the 2 here and they'll get 3x equals 15. Well, something is left out here. And I don't want to see this unless you insert an equal sign here, because what you're really doing is you're adding the left side of an equation to the left side of an equation, the right side to the right side. When you add things that are equal to each other, you get things that are equal to each other. And that's what this is doing. Okay? If you have the equal sign here, if you don't have an equal sign here, I don't want to see it. It's a detail that I will insist on. Got it? Now, everybody's going to screw it up because everybody's used to doing it that way. But I'll call you out on it politely. At least the first couple of times. Okay. And then, you know, after there, it's going to be the same as this. Okay. So just understand that you're adding an equation to an equation. You're not doing something magical. Okay. Also helps to keep things aligned. And I see a lot of mistakes people do in this. But they probably make the same mistakes of doing it in a traditional way. Okay. Now, the only other one is this one, which is really no harder than this one, except it's got a little extra detail in it. You have to use the distributive law. Okay. And I shouldn't have put an underline there. Should have put an underline. Okay, seconds. Okay. Distributive law says you can multiply the 2 by the 3x and multiply the 2 by the 4. Okay. You know, this times all this is this times this plus this times this. If it was a minus, it would be minus this times this. Now we'll go over these rules and we'll do them in detail. But I think everybody is kind of on track with most of that. If you are, we'll get you there. So we multiply 2 by 3x, we get 6x. Multiply 2 by 4, we get 8. Okay. Then the other side is 5x minus 2. All right, now what do we do? It's a little more complicated because you got x's on both sides and you got numbers on both sides. What I want to get it down to is x equals something. So what I'm going to want is to have my x's on this side and all the plain numbers on that side. So what I do is I'll write it down the way let me write it down. Okay, just noting, here's my left side, here's my right side. I subtract 8 from both sides, which gives me 6x equals 5x minus 10. Okay. Then I subtract 5x from both sides. Well, you can do these terms in any order. So we do the 5x minus 5x first, which gives you 0. You end up with negative 10. 6x minus 5x is just x, and you get x equals negative 10. Another thing you do with any equation is you check it. Okay? So I often do something like this. Here's my solution. I take my solution, I plug it in for x. And that gives me replacing x with 5 gives me 3 times 5 minus 2 equals 13. That's 15. Minus 2 equals 13. 13 equals 13. And that checks. Okay. And we could plug the minus 10 in here if I did this right. 3 times minus 10 would be negative 30. Add 4, you have negative 26, multiply that by 2, you have negative 52. Negative 10 times 5 is negative 50, minus 2 gives you the negative 52, so you have negative 52 is negative 52. Okay? Now you probably don't want to do that in your head. I strongly encourage that everything, any equation you solve, or any problem you solve, you check it. Because that gives you immediate feedback on whether you got it right or not. Now, if you're in OpenMath will give you feedback and then, no, that's wrong. Okay? By checking it yourself, you often figure out why it's wrong and what you did wrong. And that's a very efficient way to learn. Realizing you made a mistake, going back and fixing it, you learn more than you do with almost anything else. It's a very effective use of the few minutes it takes you, or several minutes, it may take you an hour, okay? But if you figure it out for yourself, then it locks itself in your memory and in your understanding in such a way that you're likely to get it right the next time. And you're likely to understand a whole lot more about everything else you do, okay? So I really emphasize checking, and I kind of want to see that in your notebook. Not necessarily on every problem, but on every type of problem. Okay? Especially a problem that you might have gotten wrong. If you do a problem and OpenMath tells you it's wrong, go back and check it. Okay? See what you learned by checking it. And then write that check into your notebook. Show me you know how to check things. And if the check is quick like this one, I mean, it takes you an extra 20 seconds to write this out. Okay? And you don't have to do all the arrows, I do that. But just make sure you see how the problem flows, or hopefully you see how the problem flows. Okay? Okay. Well, those are the quiz problems. I'm going to pause for a second. Make sure I know what's coming up. Okay, now we have the assignment of adding and subtracting fractions coming up, and assignments on order of operations with fractions and order of operations in general. I don't think people have too much trouble with order of operations, so I'm not going to talk too much about that. But if I do find that people have trouble with it, we'll patch that up, okay? So let's say we have 3/4 plus 5/8. Now I'm just going to show you the procedure for doing this. We'll talk a little bit more next time after you've done it about why we do the procedure, but it's kind of obvious, okay? And a little bit more about how we might use prime factorizations and so forth, which we're not going to have time to talk about today. Okay, so to add these, I have a lot of trouble making 8s. This chalk wants to resist me. Eventually I'll learn maybe. Okay, if I do this, I haven't changed the value of this expression. Because all I've done is I've multiplied this number by 2/2. Now, how would you simplify 2/2? What's 2/2 equal? What do you get when you divide 2 by 2? You get 1. Okay. So I've just multiplied this by 1. I haven't changed its value. But now it's 6/8. I had to use 8, didn't I? Plus 5/8. Okay. And now the denominators match up. So I just say, well, how many 8ths do I have? I have 6 of them, and I have 5 of them. It means I have 11 of them. 11 what? 11/8. So it's 11/8. Now, there are more formal ways that can be demonstrated, but at this level, I think that's not a bad way to do it. Okay? Everybody understand that okay? Now, if we had a little more time today, we were trying to kind of compress a lot of stuff because of having missed Monday. We really don't want to get behind. We really want to get through the elementary algebra and a little bit of arithmetic, which is what we're doing here because we're going to do algebra with fractions later. Okay. We want to get through this as quickly as we can. I have left room in the schedule where we can slow down and I can rearrange assignments a little bit, but I definitely don't like to do that at the beginning when we're just basically reviewing elementary school arithmetic, okay? Because I think everybody can get the elementary school arithmetic. Okay. As we get into the algebra, we'll see how things go. And let's say we got 2/9 plus 5/6. Okay. Now here, it was kind of obvious. Okay, the way we think about this, when you look at this, you think, oh, the denominators are different. What can I do to make them the same? Well, clearly I can multiply 4 by 2. Okay. But I can't multiply the 4 by the 2 because that would change the value if that's all I did. I have to multiply 3 by the same number so I don't change the value. Okay. Now here, there's nothing I can multiply by either of these numbers. It'll give me the other one. Okay, so I've got to find a common denominator, right? A number, two numbers that I could multiply these by would give me the same result. Okay, so there are a lot of ways I can do this, and OpenMath will show you some of those ways, and I'll show you prime factorization next time because it nails it and it's not that hard to do. But okay, I'm just going to claim, well, what can I multiply 9 by? Well, first thing I can multiply 9 by 2, right? It gives me 18. Is there something I can multiply by 6 to give me 18? Okay, well, I just found it. So I multiply 9 by 2 and I multiply 6 by 3, and now I've got the same denominator, right? But I can't just multiply 9 by 2 and multiply 6 by 3. Got to do kind of what I did here. So I'm going to write this as so. 2/9. Leave myself a little room. And 5/6. I want to multiply this by 2. I'll do this. I know if I multiply 9 by 2 and 6 times 3, I'm going to get the same thing. Right? I'm going to get 18. I'll be able to add the fraction. Multiply 9 by 2, I've got to multiply the numerator by 2, right? If I multiply this denominator by 3, I've got to multiply the numerator by 3, because we can see that this is still going to reduce to 2/9. And this will reduce to 5/6. So I've got 4/18 plus 15/18. And now I can add these guys. Okay. Now later, these will be algebraic symbols. They won't be numbers. You're going to have to understand this process. If you don't understand it here, you won't understand it there. And it gets pretty hairy, but if you understand this process, it's just a lot of symbols to write down. We know what to write down. It's not that hard. Not that easy. It's not that hard. Okay. Well, that's really the basics of it. That's how you add fractions with different denominators. Since we've got a little bit of time, I'll quickly show you what we do if it gets really ugly. Okay. So let's say I have okay, 5/96 plus 17/160. Can you find me a common denominator? Probably not in your head, and if so, probably not very quickly, okay? So what you do is you say, okay, here's 96. I can divide 96 by 2, gives me 48. I can divide that by 2, gives me 24. I can divide that by 2, gives me 12. I can divide that by 2, gives me 6. And dang, I'm dividing by 2 until I get to the last number, which is 3. So this is 5/2 times 2 times 2 times 2 times 2 times 3. Okay? Make sense? And this is 17 over, well, I do the same thing with 160. 160 divided by 2 gives me 80. Divided by 2 gives me 40. Divided by 2 gives me 20. Divided by 2 gives me 10. Divided by 2 gives me 5. So the denominators have almost the same structure. It's just that you got a 3 here and a 5 here. Okay? Now, we'll go into more detail on this, and you're not going to have to do this with any of the problems I think on your homework. At least not something as long as this. You might have to do a little bit of it, which is why I'm mentioning it. Okay? So that's going to be 5 over, I'm tired of writing all those 2s. I'm going to write that as 2 to the 5th. Okay? Times 3. Plus 17 over 2 to the 5th times 5. Now, what should I multiply the denominator here by and the denominator here by in order to make them the same? Well, this one's got a 5 and this one doesn't. So I better multiply by 5. This has got a 5, this has got a 3, and this one doesn't. So I better multiply this one by 3. And now the denominators are going to be the same, aren't they? Because each of them has a 2 to the 5th, and 3 times 5 and 5 times 3 is the same thing, okay? But of course, I can't just do that to the denominator. I got to do that to the numerator. And then I get 25 over 480 plus 85 over 480. And check me, I'm doing this arithmetic in my head, and sometimes I make a mistake. I think I made one back in 2014. No. I do this kind of quickly, you check my arithmetic, okay? I usually got it right, 100 years old, so doesn't always work out. That's 110 over 480. Okay? You can do a prime factorization of 110 and see what factors match up with factors of this. If you did that, you would end up with what? 2 times 5 times 11 over 2 to the 5th times 5 times 3. 5 will divide the 5, 2 will divide 1 of the 2's. That's going to be 11 over 2 to the 4th times 3, which is 11 over 3. Yeah. Okay. Now, you don't have to actually understand that step. I'm just saying that the prime factorization thing allows you to do things you wouldn't otherwise be able to do very quickly. And it can be done real quickly. And it's okay to use your calculator to do it. If you're dividing by 2, you shouldn't need the calculator. But you see me make mistakes. You can make mistakes too. You know. When you get to the point where you're a little uncertain about your arithmetic, check it with the calculator. Do as much of it as you can without the calculator, because you develop a better sense of numbers if you do. Okay. But don't spend hours doing something you can do in minutes on a calculator. Okay, good luck, get the homework done. I think everybody knows where to find the assignments. If you're a distance student and you're still listening, congratulations. And I'll be emailing you. We'll see how things are doing, okay? Probably later today. Don't walk